Hey, good afternoon, everybody, and welcome to episode 59, in which we're going to explore dual stack with, kubeadm, Kind, and Cilium. So we're going to be playing a bit with all kinds of fun stuff. We're going to be playing with dual stack, basically making it so that pods can receive an IPv4 IP address and an IPv6 IP address. I would like to give a big shout out to my really good friend Cal, who did a ton of the work behind this particular feature. I remember this was quite a lot of work. Him and Lachlan and a bunch of other folks there at Microsoft actually did quite a bit of this, put an incredible amount of effort into this particular piece of work inside of the Kubernetes project as part of like kubeproxy and also just enabling the APIs for all of these things and the node object and the pod object, all of those things. Prior to that work, Kubernetes could be deployed in IPv4 only mode, probably clearly the most common solution out there today, and also in IPv6 only mode, which was not all that common, but had happened at a couple places. And then with this work now, you have dual stack, the ability to deploy in both modes, and then to kind of enable both features inside of the cluster. So today we're going to be exploring all of that. But before we do that, hello, I hope that you are having a great Friday. And if you're out there watching, just give me a thumbs up in the chat. Let me know that you're interested and that you can see and hear me, and that we're going to move forward with the rest of the show here. All right. So in our notes this week, as always, you can always go to hackmd.io/echo live and see the notes. But as usual, I'm just going to go ahead and copy the URL and paste it into the chat. Hello, Tracy. Good to see you too. Yay. Hi. I'm looking forward to coming up here pretty soon. Can't remember the exact dates right at the moment, but I'm going to go hang out in Zurich with Tracy, and that should be a ton of fun. Sadiq, checking in from Amman, Dubai. Good to see you, Sadiq. Awesome. All right. Well, let's get started here. So our notes, as I said before, the eBPF Summit registration is open. That's actually one of the things I'll be doing in September. So probably it's going to be that week, the September 28th and 29th week. I'll be in Zurich with the rest of our community team. So Tracy will be there. Liz Rice will be there. We have quite a few other folks that are going to be present for that event. This is actually a part of how we're doing a thing called Hive Time here at Isovalent, where a lot of people who are focused on a particular area all fly to one place on the globe and spend some time together, because so much of what we do as a remote first company is remote that it's nice to actually have opportunities to actually see each other. Hello, Bora. Good to see you. So that's going to be exciting. If you're interested in registering for this, you can register for it. You can also join the Summit Slack. There's going to be watch parties. And so in here, there's going to be, the Zurich one, which is likely the one that I'll be spending my time at. There's one in Berlin. And if you would like to host one in any of these locations, there's actually information on how to do it. Tons of information about the show. It's going to be really a lot of fun. I'm really looking forward to it. Yeah, that's going to be a blast. Make sure to register. All right. It's going to be a busy couple months because we have eBPF Summit, then we have eBPF Day at KubeCon, and then we have KubeCon, and it's just going to be a blast in Boston. Hello to the LinkedIn user. I really wish there was actually more information here that would actually tell me who this was, because all I have is like in the chat, I just see LinkedIn user. Very anonymous. Anyway, hello, glad you're here. In other news, we have a new eBPF news episode. So if you're interested in these things, you can actually subscribe to this. But let's just take a quick look through and see what the news is this week. Hello, Maz. Is it Maz or Mose? I'm actually not sure. Either way, good to see you. Hello, Mark. Oh, so LinkedIn actually does show me who you are. I guess maybe you have to be logged in. And then LinkedIn user is just like the not logged in LinkedIn user, possibly. Interesting stuff. All right, so in the news this week, we have the Cilium paid mentorship opportunity to help improve the release security of Cilium and get paid to work on open source. Apply by August 25th. This is something that you're interested in. I think that ended yesterday, the application process. So probably we found somebody. Journey to libBPF 1.0. Awesome to see the project reach this milestone. Oh, that's a cool logo. Very robotic. Nice. And it's a pretty interesting blog post talking about what went on to get the Go library to libBPF. Like all of the contributors. That's pretty cool. I like that they just linked it right in. Lots of great contributions. Quentin, Mr. Dan Borkman, lots of folks out there contributing to this stuff. There are some breaking changes. So if you're actually interested in writing eBPF code, this is actually going to be pretty relevant to you, but it's basically the libBPF reaching 1.0. There is a system daemon for managing eBPF programs coming out of Red Hat, which looks pretty interesting. I haven't played with any of these things so far. There is a port knocking tool based on eBPF, which allows you to remotely open a TCP connection while being invisible to port scanners. That seems interesting. I wonder how they would be able to do that. And then a research project that aims to detect kernel exploits with eBPF. The goal of the project is to make attackers' lives harder and ultimately prevent out-of-the-box exploits from working on the vulnerable kernel. That's an interesting project also. Decrypting SSL at scale with eBPF, libBPF, and Kubernetes. So this is capturing all HTTP, MySQL, and Postgres requests and queries with K8's cluster without the need for a reverse proxy, a service mesh, or a sidecar container. Very nice. Definitely the right direction. Like this is kind of where we're headed here with some of our stuff as well. So where did that article come from? Contain IQ, Fred Letts. Poorly documented with regard to attaching to TC programs. We spent many hours comparing trace logs. Oh, nice. So likely what they're doing here is basically deferring the encryption. So using probably kernel side encryption and then capturing the actual data. That's pretty cool. Hooking libSSL. Interesting. Wow, this is a really interesting article. This might be a good read if you're interested in TLS and how this is working. So they made TLS one. This is taking a very different approach than the one that I've seen that we've been working on here on the Cilium project. Very interesting stuff. So anyway, let's keep moving. There's lots of stuff happening in the ecosystem. There's Cilium and eBPF with Thomas Graf of Isovalent coming up in episode 30, or, I guess looking back at episode 30. We have Tanzu Service Mesh using eBPF. That's something I didn't know about. That's kind of new, exciting. And then there's a how-to getting started with Kubernetes and observability, monitoring Cilium in your Cibo K3s cluster with Prometheus, build a Kubernetes cluster from scratch. Nice. That should be a pretty interesting one. 4 and 5. Very cool. Deploy the Hubble adapter for open telemetry. I think, are these coming from Nico or are they coming from somebody else? Tony Norland. Wow, go Torty. Wrote a whole thing about how to do this. Looks very similar to me. Very cool. I'll have to check this out. This looks like a really interesting article. Again, leveraging BPF or Cilium and Kubernetes. So, wow, shout out to Tony there. Pretty in-depth article there. All right, well, that's our news for this week. There's lots going on. Last week, we actually got to welcome Nick, who's going to be part of our service mesh effort here at Isovalent. So that's actually very exciting. And then I'm not sure what's going to be up for next week. Yeah, that newsletter had a lot of stuff going on for it. And you can find a link to that newsletter if you just go to that link that I just put into the chat, the HackMD link, Echo Live episode 59. It'll be that very first one. And it's actually just using the ISO go-to shortener. And so you can go to echo-news-13. That's how you can get there. All right, next up, let's play with this stuff. So this is kind of pointing toward the configuration for dual stack support with kubeadm, because I wanted to show kind of like some of the, they cover some pretty interesting stuff in there before you begin that I thought we should talk about real quick. And then we will get into how to do the thing. All right. Your Kubernetes cluster includes dual stack networking, which means the cluster networking lets you use either address family in a cluster. The control plane can assign both IPv4 and IPv6 to a single pod or service. Before you begin, you need to have installed. So we're going to be leveraging kubeadm to do the install, and we're going to take a look at how that's going to work. But we're going to be using an existing tool set that we've talked about quite a bit here on this show, which is this tool set here, kind.sigs.k8.io. Kind is a way for creating Kubernetes clusters out of containers, right? So instead of machines, like physical machines or virtual machines or AWS machines or whatever kind of machines, we're actually using Docker containers, and we're running systemd inside of those Docker containers, and each Docker container has its own container runtime pre-configured. All of that stuff is handled, and then the way that Kind stands up the cluster is it leverages kubeadm under the covers. And so anything that is supported in kubeadm is also supported in Kind. So that's actually how we're going to go about testing this out. So we're going to be leveraging Kind to do this configuration. And basically, Kind is going to handle this bit for us, this kubeadm init piece, and it's also going to handle the join piece for us. So all of this is going to be handled for us. We don't have to actually do all of that manually. We could, but we're going to save time and not do it manually. A single stack cluster just includes the pod subnet and service subnet. This is the default configuration. But if you wanted to do a dual stack configuration, you can see that things are a little bit different. We can see that the pod CIDR and the service CIDR include two different subnets, an IPv4 and an IPv6 subnet. All right, so let's test this out. Let's test out the Kind piece where we actually spring this up. Before we can do that, I wanted to take a look at the configuration, and then we'll look at networking. And then inside of here, multiple details of cluster networking can be customized under the networking field. Kind has support for IPv4, IPv6, and dual stack clusters. So remember, there's three configurations. It's like, there's the IPv4 only, IPv6 only, and dual stack. And we're going to be working on dual stack today. This is actually true of the same is true for Cilium. Cilium can be deployed in IPv4 only, IPv6 only, or dual stack. So the first thing they say is if you're going to run an IPv6 single stack cluster using Kind, if the host that runs Docker containers support IPv6, most operating systems have it enabled by default, but you can check on this to see if it's been disabled. So I don't think I disabled it on my local machine, but that's actually a really good question. Take a look. Disabled 0. Good. You should see. Oh, sorry, I went through that pretty quickly. So basically what I'm doing is I'm doing a sysctl, and I'm outputting the sysconf for this particular value, net IPv6 conf all. And this would disable all IPv6 on the system. And I'm just checking to see if that's 0. If it were 1, then that would mean that I had disabled IPv6 inside the cluster, or inside of my node, inside of my laptop. Yeah. If you're using Docker on Windows or Mac, you will need to use the IPv4 port forward from the API server from the host because IPv6 port forwards don't work on these platforms. We're using Linux, so that's all fine. And then here are the configuration parameters that we need to set in kind to be able to wire this stuff up, right? And so I'm looking for this one, which will enable dual stack IP family. And then down here in the API server list and import can be customized with the following: POSNet subnet, service subnet. And I think that's all we really need to look at. So if we wanted to set IPv6, I think we would have to actually pass that multiple subnets, but let's just try and see what happens and look at the configuration here. So CD 59, actually it's just 59. Here's our kind configuration. Our plan is actually to disable kubeproxy and to disable the default CNI, and we're going to bring up 4 nodes. Now, we still have to enable that IPv6 stuff, so let's go ahead and do that. And the argument was up here at the top. IP family dual. Boop. Okay. And then let's see what happens when we start this up. So let's do kind, which you can grab, if you're curious about playing with kind locally. There's a reason, actually. I'm going to talk a minute why I'm using kind for this stuff, because kind lets me create all of the stuff locally without any cloud requirements. I don't have to interact with AWS or any of the other stuff. I don't have to actually have an account that gives me access to all of those things. I can use kind to explore all this stuff locally without having to pay exorbitant, without having to pay costs for all of the different environments. And this is a big reason why I think kind is such a great project, because it enables us to kind of explore the complexity of Kubernetes, or just learn everything about particular features or functions, or play with them and do all of those things without actually a high cost. Obviously, it's a cost in time, but it's not a cost in real material money in GKE or Minikube, or or in GKE or AWS or any of these other cloud environments. That's a big reason why I'm a big fan of kind. Kind is also used heavily in testing Kubernetes. So the function of dual stack inside of Kubernetes is actually tested with kind. So that's actually pretty cool. All right, so there is our environment. So we're going to do kind create cluster config. And this should actually bring up a cluster with no kubeproxy, with no CNI deployed, but some of the other stuff should already be configured. And we're going to take a look at how that's configured here in just a minute. Oh, looks like I'm pulling down a new image. I guess I'm looking at a brand new release of kind. Because usually, oh, that's what it was. I actually just recently did one of my favorite commands for cleaning stuff up, which is this command: docker system prune all volumes. And what this does, if you're running Docker on your machines and you want to get rid of all the cruft, free with the free version of Docker. Yes, correct. Yeah, that's true. It is very lightweight. So what this command does is it actually just cleans out all of the trash and cruft and stuff that's inside of the system. Now, I would not recommend doing this if you have long-running daemons or systems that or data in volumes that you care about. But for the most part, I'm using this to kind of stand up kind clusters and build things, and all of that is pretty ephemeral. So every so often, like once a month or something, I run this command and usually free up a good amount of space. Hello, Bojanch. Good to see you. More kind love. I agree. And then free with the free version of Docker. Also true. Yeah. All right. So our cluster is up. Yeah. kubectl get nodes wide the describe node and see what we see here. Aha, look at that. So we have a pod cider, FD0064, and we have the pod cider from the default cider, pod cider that's available to this node. So this tells me that this is configured in a dual stack mode, right? So both pods should be able to get both types of IP address. And the way I'm looking at that is I'm just basically looking at the pod ciders. Now, let's take a look at the kubeadm configuration real quick. So I'm going to docker exec in to my kind control plane. I'm going to figure out what I missed. Oh, no N. cat etc cube. Actually, it's find kubeadm.com. So this is so just like we were looking at in the Kubernetes docs, how we're gonna the configuration that we need to provide to be able to pass the dual stack parameters into the cluster. These things have already been populated for us, right? So there are those variables set for us. Here's the service cider. We're using FD0 to 96::/112, and for the service cider, and we're using a pod cider like this. And so I think we're ready to get going. So there's node IPs, getting both node IPs. And actually, this is interesting. So if I were to do better, then we can see that we have both IP addresses hanging off of ETH0. Awesome. And if I do kubectl, yeah, okay. So that shows me that basically the cluster is set up correctly for IPv6. If I do get pods -a, I can see that there is no kube proxy deployed at all. Core DNS is pending because there is no CNI yet, and that we're pretty much ready to deploy the Cilium CNI. You know, Rancher is another really great option. Yeah, it's not the only way. It's true. A lot of folks I know that are trying to explore or learn or discover stuff, actually, I mean, I really appreciate, let me say it this way, I really appreciate that Rancher actually has also solved this problem, right, of making it available for people without, like, you know, the ability to run up a bill on a cloud environment somewhere, right? You can actually run K3S or K0S or Rancher's RKE or RKE V2, any of those things on local machines. And you've seen me do that here in the past here on this show. So I really do appreciate it when people try to make this stuff more accessible and that kind of thing. All right. So the next thing we're going to do is we're going to go ahead and take a look at the configuration of Cilium to do this. So what I'm going to do first is I'm going to go ahead and grab a default values file for, actually, you know what, let's try doing this. Cilium install. So because I'm going to be replacing the kube proxy, let's talk about this for a second. I talked about this in the last episode a little bit, but like because I'm replacing kube proxy, I have to configure Cilium to know how to actually reach the IP address of the API server without relying on the internal representation of the IP of the Kubernetes API server. By that I mean, in most clusters, if you're going to deploy a CNI, because kube proxy is already present, you can actually just interact with the kube API server via this Kubernetes default service. Get service a-oy. There'll be a default Kubernetes service, or there'll be a Kubernetes service in the default namespace, and this is represented by the first IP address in the service cider. And that service is actually how most things inside of your cluster interact with the Kubernetes API. And since Cilium needs to have the access to the Kubernetes API to determine, like, you know, how to configure all of the kube proxy stuff on our behalf, then we have to basically give it access to that API server without being able to rely on this on this service that is basically implemented by some form of kubeproxy. It's a circular dependency, right? Without kubeproxy in place, you have to give it access some other way. This is actually true of kubeproxy as well. So, all right, so let's do our Cilium version. I'm running 12 of the image, and then we'll do Cilium install helm set history for that. Okay. This is our Cilium install command for just the regular install. And let's just walk through these parameters real quick. The first thing I'm doing is I'm setting K8 service host. And this is actually going to be how I go about configuring the cluster to understand how to actually reach the API server. Inside of the Docker container, this will be resolvable. So you'll be able to resolve kind control plane, and then the service port is going to be 6443, and then kubeproxy replacement strict, telling us that we're actually going to replace kubeproxy. And then there's a few more parameters that we want, right? So we want to enable, let's see here. Boop. Okay. So we also want to enable IPv6 inside of our cluster. So this is the Helm values for 1.12.1. And what I'm looking at here is basically just how do I enable IPv6? It should be IPv6 enabled true. By default, it is false. So let's go ahead and enable that. In theory, that should be enough to get us started. So let's go ahead and take a look at what happens here. Excuse me. Oh, itchy nose. So we've determined that it's kind. We're going to use tunnel mode. We're replacing the kubeproxy. We're using IPAM mode Kubernetes. So in theory, that should be everything that we need. So let's go ahead and let this get loaded up here. Hello, David. Good to see you. I hope to see you again later this afternoon, actually. I think we have an appointment later today. So the question is, why don't you pass the Kubernetes service instead of the control plane hosting to Cilium CLI? And the reason, Moz, is because there's nothing to satisfy that service at the moment. Because I'm replacing kubeproxy. If I actually let kubeproxy get installed in my kind configuration, then I could just pass it the service and everything would be fine. But in this particular configuration, I'm actually replacing kubeproxy, so I have to do the work of telling it how to find it. All right. So Cilium status. It's like we're all deployed. Let's see. So we've got everything deployed here. The next thing I want to see is, let's do this. Let's do kubectl get Cilium node. Wow, what's happening there? Kubectl get Cilium. Yeah, okay. So I want to see all the Cilium nodes, and this is actually an interesting output. So if we see kubectl API resources, it'll basically list all the things that your cluster knows about that are extensions of the Kubernetes API server, or that are just included in the regular Kubernetes API server. So on any of these objects, you should also be able to do an explain or a get, right? And then the neat thing about the way this is laid out is that that's the whole name. So these are bindings, config maps, endpoints, all the things that make up the the objects that the Kubernetes API server knows about. But then there's also a short name, like daemon sets can be shortened to DS. And in our case, Cilium nodes can be shortened to CN or Cilium MN or Cilium N. kubectl get CN. And we'll do it for the control plane. All right. So inside of this configuration, this is basically how Cilium sees the configuration of the underlying node. And there we see that we actually have an IP address associated with the Cilium internal IP of the node, the internal IP, the IPv6 and the IPv4 internal IP. And then we also see the health check IP address of both sides, and we see the pod sliders of both sides. So it looks to me like Cilium is configured to be dual stack. The next thing we're going to do is we're going to go ahead and deploy some stuff. So let's go ahead and do a kubectl create deployment image equals go emit server replicas 10 port 8080. I'll have to go to name. Go. Oops. All right, so that should get us something deployed. Deployed here. Let's just take a look at one of the pods here. tj.show and sure enough, we can see that the pod has 2 IP addresses. So right here under status, we can see the container statuses. We can see the pod IP. It got 10.244.3.148, and it also got FD00 10.244.3.99 BE. Very cool. Let's do kubectl expose. I want to play with services here for just a minute. And before I do that, I want to go ahead and jump back into our docs that we were looking at. Let's see. There we go. Because down here in the docs, it says validate IPv4, IPv6 dual stack. And so since this is documented, we might as well check it out. The value of having it is that there are actually lots of different ways you can configure an IPv6 cluster. And actually this is a really interesting point that why do IPv6 addresses to the pods or the services or that kind of stuff at all? And one of the main reasons is as you start is IP exhaustion. For the most part, a lot of folks are running into scenarios wherein within their infrastructure, they're running out of IP addresses to allocate to new projects. And the result of that is that they're basically trying to come up with ways to reuse IP space or to maybe make use of IPv6 in their particular environments. In Kubernetes, there are again lots of ways to deploy things, especially with Cilium, right? So Cilium can actually deploy using IPv4 in a routing mode, which means that all of the pod IPs themselves become routable, and we announce those pod IPs that are associated on each node using BGP and all of that kind of trick. And you can imagine that because you're basically making those IPv4 IP addresses routable, that means you actually have to have space in your underlying infrastructure's IP addressing scheme to allow for all of those pods to, you are to be allocated from routable IPs within your underlying infrastructure. And that can be pretty tough, right? Because if you think about it, like what are the IP addresses that you can actually use to route stuff within your underlying infrastructure? And how big an enterprise do you have, right? If you're a Google or a Yahoo or a Twilio or any of these other large companies, you've probably allocated quite a bit of that IPv4 space already. And things get pretty out of hand. With IPv6, you can actually, basically make quite a bit of more. You can make use of a much larger address range. And so if you're going to make that routable decision that all things should be routable, you can actually make that routable decision such that it actually applies to a much larger range. And you don't have to worry necessarily about exhausting it. So instead of giving like a /24 or /23 IP address allocation to every node, which is like 250x or 200, which is 254 hosts on a particular node or 254 pod IPs that could be available to that node. You can actually give it an entire IPv6 /24, which is quite a bit more IP addresses. So we have already done this. We've seen that we have an IPv4 and IPv6 address. That's what we were just looking at. Oh, look. That's cool. Let's take a look at that. I didn't realize that. It makes sense, but I didn't realize that if you exec into a pod, I also forgot that the echo image doesn't have a shell. Can we reach the internet? APK update. Add ping. I always forget which command it is. APK search ping. Bah. Do I already have it? I do. Okay. Nice. This host is 10.244.2.745e, and I'm able to ping another host using its IPv6 address. We have IPv6 connectivity in the system. Nice. But what if I use private IP ranges for pod networking? I mean, it's the same thing. You're still going to run out of address space eventually, right? So like even the private IP ranges, like if you think about what's available, there's actually an RFC for that. If you go to RFC 1918. These are the CIDRs that can be used for private addressing inside of your organization. And that doesn't matter like where, whether that spans your local organization and what you have deployed in the cloud, and you connect via routing, all the other stuff, right? So you have the entire 8. You have 172.16/12, and you have 192.168/16. Now, with Kubernetes, there's also the option of actually making use of an overlay networking model, where instead of actually routing all of those pods, you can actually make it so that only those IP addresses are only viable within the cluster itself. And if you do that, then basically you can reuse the same CIDR over and over and over again because there's no overlap, right? Like you're not actually routing out. But there's a catch. And this is an important catch that I've run into in a number of different production environments, which is that, like, say you decide, you know what, I'm going to use this 172.16/12 for all of my for all of my Kubernetes deployments. And that means that for every Kubernetes cluster that I have, I'm going to allocate it a /12, and it's going to be the same /12 for every Kubernetes deployment. And it won't have a problem because every cluster is going to have its own implementation of that, right? So it'll only be locally routable within that cluster as part of the overlay network associated with that cluster. So then the question becomes like, how does a pod within your cluster access an external service, a service that is actually made available in your underlying infrastructure that is a shared service, like a database or some other service that you have deployed within your infrastructure? And if for some reason that overlaps with the private CIDR that you've given to the cluster, then basically what ends up happening is that you end up dropping that traffic before it can actually leave the cluster, because you've allocated that CIDR, that 192.168 CIDR or 172.16 CIDR, to the cluster itself. And so it assumes that everything within that 172.16 range is known only in the overlay network. And if it's not known in the overlay network, then it throws it away. So overlapping CIDRs, even with existing underlying infrastructure, is actually a real problem. So whatever pod CIDR you allocate, regardless. Hello, Marino. Good to see you. So whatever pod CIDR you allocate to your cluster, regardless of whether you're using an overlay or whether you're using whether you're making it routable, it's still going to be super important that you actually don't overlap that with services that you've otherwise defined in your infrastructure that you actually need those pods to be able to access, right? Otherwise, things won't work. Best example of this one I've seen is actually, of course, it's DNS, but an example where the company had set the IP address range for their DNS servers on a small subnet that was a part of the larger subnet that you've allocated to the Kubernetes cluster, and then basically the core DNS pods, when they were actually trying to access the DNS servers, were getting null routed because they were the underlying node assumed that all of that entire subnet was only known in the overlay network. And so the core DNS servers couldn't reach the DNS servers that were outside in the shared infrastructure. That was a pretty interesting problem. Yay, Q-Puddle. Yay. Yeah, both y'all are awesome. I'm a little jelly I didn't get to hang out with both of you in such a wonderful place. All right, so where are we at here? So we've got our things deployed. We've been able to prove basic IPv6 connectivity. We've proven that we have, let's play with the services side of things. That's what I wanted to do next. So going back to that validate piece. So validating services. So let's go ahead and make a deployment of a service and see what we see. I can't remember actually. So you see this value here, IP family policy. This is actually how you can configure a service to be, whether it's IPv4, IPv6, or dual. And single stack would, I think, default to whatever the default configuration is. And if it's dual stack, is it dual stack? IP family is IPv6, single stack. And then there is a dual stack one also. There we go. Preferred dual stack. So let's play with this and see how this works. So let's do that. We're going to make a number of services here. So let's do kubectl create service. Just by the default one. Type will be, we'll just leave the default type cluster IP. Actually, let's do this. Expose deployment echo. If we just do that by default, let's just take a look at what gets created. Get service. So by default, it actually creates a single stack IP family IPv4 service. So the default service that it creates, even in a dual stack cluster like the one that we're in, will actually just be the IPv4 service. But what if I wanted to actually make a dual stack or an IPv6 only service? Let's see this point. Maz says, what will happen if we run out of IPv4 addresses in case of dual stack? Does the new pod get only IPv6 addresses, or it won't be possible to create a new pod? That is a really good question. I think what would happen... Wow, that's a really interesting question. I think what would happen is the pod would not be able to be created. We could test this out and just see what happens. It's a really good question. I don't know if I want to jump down that rabbit hole right at the moment. I want to finish playing with the different services, and then we might come back to that one. But that is a really good question. Yeah, if the IP range is exhausted, exactly. Yeah, if the IPv4, because obviously you're probably going to run out of the IPv4 addresses before you run out of the IPv6 addresses. So the question is, like, what happens if you run out of the IPv4 addresses? Yeah, good question. I think what would happen is that basically this is going to come down to the interaction of the CNI, right? So kubelet says, make me a pod. And it interacts with your container networking implementation. Your container networking implementation tries to allocate the IP addresses for that pod. And if it can't, then it errors. And I believe that the error is going to float up regardless of what layer the error is going to show up at. Like, so if the IPv4 exhaustion happens, then that's still an error, and it would bubble up as a top level error regardless of whether that it was still satisfiable with IPv6. So I think it would actually, it's not even really about getting scheduled. You would still get scheduled. It would just be that the kubelet that you got scheduled to was out of IP addresses. And so it wasn't able to actually instantiate that pod. In that instance, could you force it? I don't think that you could, because it would be an error. Yeah, I don't think... It's an interesting question. What ends up happening most frequently is that people actually configure like IP ranges or multiple subnets that can be allocated to pods. So, for example, we've just pushed a new feature, or relatively new feature, into Cilium, wherein you can, where we will dynamically allocate another IPv4 range to the node when you have exhausted it. And that seems to be a more common request. It's like, when I do run out of IPv4 addresses, I want to be able to dynamically allocate another CIDR to the node where the allocation is, used up, so that we can make use of it a little faster. I think I would have a different problem if I did that. Instead, what I'm going to do is create another kind cluster and then change the actual pod CIDR allocation size. I'll make it much smaller, and then I can exhaust it a lot easier. So before we do that, let's get into these services, and then maybe we can jump into that other thing and take a look. So next thing I want to do is I want to kubectl expose. We'll do the same expose, and we'll do run -o YAML, and we'll just create P6. And then dual. And basically what I'm doing is I'm just creating a couple files. Move. Should have actually probably made them YAML files. Take a look at the IPv6 one. This is just for the service. Oh, look at that. In our spec on this side, we're going to create IP families. We will make this one IPv6. and IP family policy see the typo? I typoed something here already. How I roll. Oh, YAML. Okay, so in this configuration, the name is actually also going to be IPv6. This is the IPv6 only one. And the changes I'm making to the YAML are basically telling it that I want IP family IPv6. And then I'm also telling the family policy to be single stack so that we know it knows to only give me that one IP address. Oh, fine. Gotta capitalize. Field validation. There we go. Get svc-oy. And we can see that the service was created and that it got an IPv6 address. And then the last one I wanted to create was echo dual. But this time I'm going to be a little bit lazy and do CP echo IPv6 dual. And this one, our argument was dual stack. But let's look at this to define that, what that would be. Explain service spec family policy. There we go. So here is the configuration. Let's actually just look at that one parameter because that's going to be easier to read. So this is introducing a new command, another one of my absolute favorite commands, which is kubectl explain. And kubectl explain lets you interactively read the documentation behind everything in the Kubernetes API. So in this particular case, I'm trying to understand, like, what are the valid parameters to IP family policy? And so I know that that's going to be under service. I can look under the spec or the specification for that service. And then for this particular parameter, what are the valid outputs? So represents the dual stackness requested or required by the service. If there is no value provided, then this field will be set to single stack. You can also do prefer dual stack, and you can also do required dual stack. That's actually pretty cool. So if you do preferred and it's not a dual stack cluster, then you'll only get the single IP family. But if you require it, then you just won't deploy if it's not both. Pretty cool. So let's do our echo vim dual again. Required dual stack. All right. That'll also probably include the other IP family that we care about. Here we go. Apply this, and then we'll try that exhaustion thing. One more time. I got this before we did it. Cool. Okay. I-F echo dual. I'll get SVC dual. And that is our dual stack. So the first one we created by default was only IPv4. The second one we created was only IPv6, and the third one we created was actually both. All right. Now, a couple of things real quick. What I'm actually curious about real quick is if I do kubectl get endpoints and I look at the echo IPv6. YAML. Then I'm looking at the configuration of the underlying service. And because I created an IPv6 service, it's actually going to be routing back to the IPv6 IP addresses of the underlying host, or of the backing pods. So the backend pods are going to be actually getting routed to and only the IPv6 ones. And if I look at the dual one, I'm actually really curious how this would look. Let's look. So in dual, nice. So in dual, it still prefers the IPv4 address. And obviously the IPv4 one prefers the IPv4 one. So the only way to make sure that it's going to use the IPv6 IP addresses of the backend are to actually use that mechanism. So let's do one more test, actually, out of curiosity. So kubectl get pods. I still have my bash pod. Exec-ti bash. Okay, add curl echo dual dot default gc. Interesting. Let's have the IP address of it. If I do ping 6, I shouldn't be able to ping the service IP because that doesn't ever work, but I should be able to ping the IPv6 addresses of the other pods. Interesting. So I wonder where this went wrong. I pinged the IPv6. Curl the IPv6. And if I curl the default one, services are not happy. This is to fiddle exec-ti-n system status QuickBooks. I wonder if this is there's actually not even the IPv4 service is working. So that's actually kind of an interesting problem. Looks like it is routing correctly. And if I do it from here, what happens? If I try to reach that service. This might be simpler than I think it is. Right? Get all get SVC. Go. What is the listening port? Is it 8080 or is it 80? I don't remember. Okay, let's take a look. Fine. This is actually bash. We do curl of the IP address. And not 80. Definitely is 8080. If I were to do the IPv6 address, what would happen? Same thing about IPv6 addresses. Because they have so many semicolons in them, or semicolons in them, you actually sometimes have to do stuff like this to basically tell it to use the IPv6 address and the port. So if you're going to pass a port to an IPv6 address, you usually have to do it like with brackets. Otherwise, it gets really mad at you. So it looks like it's actually connecting to the pod just fine. Pod to pod is working, but pod to service is not working. For a second, I'll take another look at the service IP. Oh, I'm a bonehead. Anybody see my problem? It's so obvious. I feel like a total maroon. All right. Perl echo dual colon 8080. Huh. Weird. All right. Proving that no matter how often you spend, how much time you spend with Kubernetes, you still get owned every so often. The IPv6 one. Oh, it works great. The problem was that my service is defined to listen on port 8080, and I was interacting with it on port 80. And of course, that's not going to work because there's nothing listening there. Anyway. Oh, yeah, everything is working. We're able to actually reach the thing. I know, yeah. Good times. All right, so let's do this other thing real quick, and then I'm going to probably bounce. I need to check my schedule real quick and see what I'm doing. Okay, actually, I have a little bit of time. So let's actually try to answer Maz's question, because I think that would be a pretty fun thing to do. So let's do that. So I'm going to exit out of this. We've proven our IP6 connectivity stuff. Things are working right. I'm going to do a kind delete cluster all. Just wipe out the kind cluster. Kind delete cluster. And then we'll do kind create cluster. Not going to work. That's not going to work. Hold on. And then what is the parameter? So what I need to do is I need to change because I'm actually using the kubeadm for the CIDR here. So what I want to see is So that's the pod subnet. I think what I want is going to be a little more complicated to try, but we're going to do it anyway. So let's do BVM. There we go. So this is the configuration for KubeADM, and I grant it's a little complex, but what I need to see is a way to describe the size of configuration on the node. And so I'm looking for what that configuration will be, which I believe to be, I don't think it's in networking, but yeah, this is just describing the whole subnet, which is not what we care about. What we care about is the size, which I think is being done by the control plane configuration. Control plane component. And then there's an extra args there. Well, there's going to be, then I believe it is the control plane that's doing it. So Q controller manager. R for the, because what's happening here, just to give you a little bit more insight, is what's happening is that when you bring up a cluster and you're leveraging the Kubernetes IPAM, which is what we were leveraging here, then basically we are waiting on the node to be configured with its IP allocation, and then Cilium will make use of that IP allocation. And so what I'm trying to do is remember how to actually tell the controller manager to allocate a smaller CIDR for IPv4. So that's allocate node CIDRs. And then is it? I think it's like a /24. Node CIDR mask size. This is my guy right here. Specifically, this is my guy right here. Node CIDR mask size. So in the interest of time, I'm going to get a little crazy with it. So let's just bear with me for a moment. Trying to figure out the quickest way to solve this problem. Probably the quickest way is to edit this. And then the configuration. So this is what we want to pass in effectively. Something very similar to that. Let's drop this in here. Make sure that's actually registered right. Medium config patches. One more line. Copy. Paste. I don't particularly want a init configuration. What I want to do is I want to pass an extra variable to the, I don't think it's a init configuration. It might be. Because I want to configure the controller manager. There we go. Oh, interesting. So I guess it will pass the arguments to... That's a relatively new thing, I think. So I want to pass this value to the cluster configuration. Find cluster configuration. Controller manager. Take a look at this again real quick. Yeah, perfect. Okay. Colon. Straw parks. And we'll do something similar to this, but we're going to change the value of it. And the value we're looking for is node CIDR mask size. Actually, no. It's the, yeah. That's our value. Copy. And then in our example, it's a colon and the value. Say 20. That works. So what this should do is it should make it so that the CIDR being allocated to the node is a /27, which is much smaller than the default. And it should mean that when we look at the node allocation CIDR for each of the nodes, then that's what we're getting. So let's try this out. And create cluster, config. Missing something here. Kind cluster configuration. API server colon. Oh. Better. Let's just move this all over here a little bit. The CIDR mask, something like that. Ah, new line. A field kind. All right, we have snatched victory from the jaws of defeat. 28, yeah, probably right. Yeah. 28 is pretty small though, but let's try it. 28. Delete cluster. And create cluster. Okay. That was some pretty crazy kubeadm configuration stuff. So thanks for sticking with me through that. If this doesn't work, this might be a future episode thing, because I don't have a ton of time left. But I did kind of want to see what would happen. I'm curious about it also. Joining the worker nodes. It'll describe node kind worker. Work. Kind cluster. Just in case. I have seen bugs before where like one value was not honored unless the other value existed. So let's try this. Starting the control plane node. Kernel exec ti dash actually no. Control plane dash cat kubeadm config. Did it take the change? Oh, it did not. Controller? Oh, that's why. It's one of those things I kind of hate, but anyway, it is what it is. So what I was just looking at is I was looking at the kubeadm configuration that's passed in by default. And the one I'm looking for is the one for the controller manager. So in the cluster configuration, here's the controller manager. Here's the extra args. Here's the existing one. I want to add a new one here. I don't see it here. Like the actual parameter of setting a smaller subnet isn't being propagated. But what I also noticed is that this stuff is being propagated, but it's incorrect, right? Because it needs to be under controller manager. Okay, so find delete cluster. Then camel case. It's always camel case because Kubernetes has a Java problem. Wait, no. Yeah. I wanted. Cannot type type string. What are you talking about? This needs to be quoted. Interesting that when we put it in the right place, it now has more validation, which is fun. Now we see it in the correct position. Yeah. All right. So now, describe node. Oh, waiting for the API server to come up. So, like it. I think this has actually failed in a way that is interesting. Yes. Here it's there. And get okay. So there is our cube config. We're waiting for the workers to come up, and that's fine. But what I wanted to see was the allocated subnet, which I don't see yet. It's just the internal addresses for now until the controller manager comes up. Get pod station cube system. Uh-oh. Log session cube controller manager. What did you not like about the information? I suspect, though I don't know for sure, that it's complaining to me. It's complaining to me because I set both or something. That's what I suspect is happening. But it's going to be way up here at the top, one way or the other. Whew. Usage of node slider mask size is not a lot. Show enough. All right. Delete cluster. And create cluster. All of this. So what happened was I set both parameters in my troubleshooting previously. I can only set one parameter because of the dual stack cluster. I can only set the IPv4 one. And that's why it was mad at me. So should be working now, though. Hopefully. And then I'm going to bounce in 20. Actually, I'm going to bounce in 25 minutes. No matter what, I'm leaving. I'll probably have to do that next time. But all right, so kubectl get nodes kind control plane -OY -OYAML. Yes. So we have succeeded. Get all cordon. Two worker three. Keep it all. Image. Go image equals echo. Actually, yeah. I'm going to show you a trick. Yeah. This is the pause container. It takes almost nothing to operate a pause container, and it basically sits with a running process that runs forever. You gotta create deployment, pause, image equals that thing, and then replicas, kitty, bam, kubectl, pause -OY. So we're going to deploy them all, and we're going to deploy them all to the same node here. Oh, I don't have a CNI installed. Cilium install that one. The moment of almost truth. The big payoff is coming, but it's not here yet because I forgot to install a CNI. Come on. Right? My gosh. I've come to expect more of myself. At least I figured it out pretty fast. Could have been sitting there for a while. Like, why isn't it deploying? Oh. This is happening because the pods existed before Cilium came up. So now if I do Cilium status, it'll tell me about the things it cares about. And if I do kubectl get pods, you can see that there are a bunch of things creating and terminating. I put it all on the same node so that I could exhaust things faster. It should all be landing on kubectl. It should all be landing on kind worker. I'll let things settle for a minute. We're getting some IP addresses. (10.244.00/28). There are 14 hosts in here. I created 50. So the rest so far seem to be sitting in creating, but if I do a log, go pause actually pod. See if we just do get events, we should be able to see our error. This is what I was expecting to happen. You get an error that says failed to create pod sandbox. Host IPAM failure, unable to allocate IP address via local Cilium agent. And because that would bubble up higher, that basically means that the whole show is stopped. So there we go. That's the answer. The answer is that because we can't allocate a pod, we can't allocate an IP address, that we stop and we can't continue. And I haven't enabled that dynamic allocation thing in this cluster, so that's basically why it's not getting a new header. Right. Range is full, yeah. Well, I hope that was, that was definitely a bit of a deep dive into like the weird KubeADM stuff and all of that. So that was a great question, Maz, and I hope that was helpful and that you all learned some stuff. It was fun to kind of play with IPv6. It's neat that you can actually allocate services that are v6, v4, or dual, and that it is also interesting to see that the defaults are, by default, it'll just kind of prefer IPv4 over everything, and that you can configure it to use only IPv6. One of the other things that I learned today that I didn't know before was that if you configure a service to be an IPv6 service, that service will only have IPv6 endpoints behind it, whereas the other two, the dual stack and the IPv4 only one, of course, will all have only IPv4 behind it. Kind of cool. All right. Thank you all so much for hanging out with me. I hope that this was, like I said, helpful, and I'll see you all next time. Have a great time. And then the exit video. Bye. Well, that's not what I wanted. There it is. Bye.